In example number 8, we're solving an inconsistent system of equations. So solving the following systems of equations, equation number 1 is x, which is equal to 9 minus 2y. Equation number 2 is x plus 2y equals 13. Now we can approach this problem in two ways. Because one equation is already solved for x, the most obvious step is to use substitution. So we're going to substitute what x is equal to, which is 9 minus 2y, into x. So replacing x to be 9 minus 2y, and then plus 2y equals 13. So now when we get 9 minus 2y plus 2y, we can see that minus 2y and plus 2y gives you 0. And therefore what's left is 9 on one side of the equation and 13 on the other. So you need to make sure that you follow through the whole way to see what's happening. So when you eliminate a variable, it doesn't mean that you should stop. You want to be able to see what's happening here. Now, 9 equals 13. That is a false statement. So this statement is a contradiction because 9 does not equal 13. So therefore, the system has no solution. Now, writing the equations in slope-intercept form confirms that the system is inconsistent because all lines will intersect eventually unless they are parallel. Parallel lines will never intersect. Thus, the two lines have no points in common. So the graphs of the equations in this example are shown. So you can see here that we have two parallel lines. Now, the second approach would be to first manipulate the equations so that they are both in slope-intercept form. So what we can do is manipulate the first equation as follows. We can solve for y by adding 2x to the left side and subtracting x to the right side. So now we have 2y, which is equal to negative x plus 9. And then we're going to divide everything by 2. So we get y, which is equal to negative 1/2 x plus 9 over 2. And then we're going to convert the second equation expressed to slope-intercept form. So again, we're going to solve for y in the second equation. So we're going to subtract x. So we have 2y equals negative x plus 13. And then divide everything by 2, and we get y, which is equal to negative 1/2 x plus 13 over 2. Now, comparing the equations, we can see that they have the same slope, but different y-intercepts. So what do we know about it when the equations have the same slope, but different y-intercepts? The lines are parallel and that they do not intersect. So this would be a second approach to be able to compare the slopes. But in this scenario, once we get a contradiction, we automatically know that it's no solution and that they're parallel lines.